questions on? Hey, you weren't here yesterday, so I kept you out of. This is from the notes. So if you want to watch the video, you're subjected to hearing me. All right, so a couple people got all frustrated because there was only a test that a quiz we had taken like sometime around Thanksgiving that some people hadn't finished up yet, and now I kind of made it count against them, and now they're all upset at me. As soon as it's done, you can get your score right back up. So I'm just.
If I get an F, it's gonna stay the same.
An F better than a 0.
No, you'll get more points than 0. I guarantee it.
And I still have a D.
I know because it's counted as a 0.
Dude, a D is a pass.
It's a 0 out of 60 right now.
I know. And just to be that big jerk, just to be the so this is you guys obviously see how I roll. I'm sorry, Sam's got the floor, so Sam, continue your conversation, please. So just to be the big jerk, I wait to put those zeros in for those people who hadn't finished it right after you guys knock this one quiz out of the park.
When my confidence was up.
Now you guys are crying yourselves to sleep. I mean, it's beautiful. Okay.
I don't really care.
It's okay if you cry yourself to sleep. I do every night.
Sarah.
Well, makes you feel better.
Yo.
Okay.
That's what they do in the group.
How did the sign homework go?
I didn't do
It
it.
was okay.
No kidding.
I just don't really understand this.
Well, ask me.
I sort of get it.
And then having a meeting.
What do we got?
17.
17.
Whoa.
Coming for the guy who didn't do it, saying 12. 17. Okay. Problem number 17. We got y equals 3 sine. This isn't 17?
No, that's
Oh.
I remember on my spell.
Okay. So this one is not going to look like our traditional one right off the bat. Does everyone feel comfortable that this has some stuff taking place to it? A little bit more. So I am going to go ahead and graph our parent function. What? I haven't done anything. I'm just making my graph. Okay. So are you okay with that, Olivia?
I guess.
I mean, it's going to be the same every time.
Okay.
The x-axis is labeled in radians, not 1, 2, 3, 4. Just a different way of counting.
Okay, but why is the y -1?
Because sine graph goes up to 1, down to -1. I'm just going to make. I'm just making my parent function.
I didn't see that.
So my parent function of sine will look like this, and I'm going to do this in yellow because I want you to realize that this does not interfere with our graph. So this is what our parent function will look like. Okay, that's the most basic sine graph there is. I did it in yellow. I know it's hard to see, so that's for the most part what it will look like. It'll keep going forever, left and right, keep doing the wave motion. All right, so what does this do?
Moves it up 1. So.
Okay, so now I'm going to change this. I'm going to change my x-axis. I'm actually going to say 1. That's no longer my x-axis. It's going to be 1. And so if this is 1, this one has to be 2, and this one down here actually has to be 0. So here's where my x-axis is down here now. Is that all right? Now I'm not too worried about my x-axis. I'm just changing what I have. So that dotted line now is my center line. That's what I'm going to go above and below. Okay? What will this 3 right here do to the whole problem?
Raise it up.
Yeah, it stretches it. It makes it go 3 above and 3 below the center line. Okay, so if the center line's at 1, so then I have to go up to 4 and down 2. So down 1, 2, 3. So down here to negative 2. Okay? So it's going to go up this high. It's going to go down this low with the center line. Cool? Ready? Ready? So it's going to shift right pi fourths.
So you just change the
Hang on.
numbers.
Does that make sense? Does everyone get why it's going to shift right pi fourths?
Yeah.
Yes.
Because it's negative, it does the opposite. Sam, what am I going to do now?
Change the numbers.
What numbers? What color?
Pi to
What color?
Blue.
Blue. I'm going to change the blue numbers. So if I'm shifting everything to the right, I have to add pi fourths to everything. So this is no longer 0. It is
Pi fourth.
pi fourths. This is no longer pi over 2. I'm going to go pi over 2 plus pi over 4, which is it pi over 6? So pi over 2 plus pi over 4. So I'll make that 2 over 4. So that's 3 pi over 4. Right?
Yeah.
Wait, I goofed. Oh, man. No, I'm good. 3 pi over 4. So 3 pi over 4. So I modified that. Now I'm going to add pi and pi fourths together. So this is now going to be 5 pi over 4. It's no longer pi. Is that okay?
Uh-huh.
I'm going to add pi over 4 to this one. So let's change that to 6 pi over 4 plus pi over 4. So this is now a 7. Is that okay? Now I'm going to add pi over 4 to 2 pi. So let's change 2 pi to 8 pi over 4 plus pi over 4. So what does this change to then? 9 pi over 4. That's supposed to be a 4, but so that's a 9 pi over 4. So does everyone feel comfortable how I changed this, 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 and this?
Yes.
Okay? So I still have my yellow basic one there, but the yellow is actually now incorrect. It's not the parent function. Now because I've changed my center line, and I've also changed my this way, but so now we have to say, okay, I still have a 0 here, or where it's crossing the center line. What is this point going to be then? What does that do? So is that a maximum?
Yeah, that's 3.
So now my maximum's up here. Because I go 3 above my center line. My center line's 1, I go 3 above it because of that 3. This is still going to cross the center line right. That was off a smidge. Still going to cross right there, which was that pi over 4. And then, let's see. This one, what is this? Is this a maximum or a minimum? Min. So my min's now at negative 2. Back to where it crossed the center line, and this is now a maximum. So I guess I didn't need all that, but boom, there it is. So I got my graph's off a smidge. So I'm gonna do that real quick. Okay, so that black dot should be here. This one should be here. Should be here. Should be here. There it goes. So the black is in now. So the only thing I had to really change on my graph was the height of my parent function. If my parent function, if that 3 out front was a 1, my yellow would have been fine. I mean, my yellow was off. I graphed it off a little bit, but let's look at another question. Oh, bless you, 17. They asked for, so the midline is this. So that's y equals 1. It's the midline. They wanted the amplitude. So it's the absolute value of that first term. So the amplitude is 3. And then they wanted the period. I'm going to come down here and show you on the period how a little bit better way to do it. Okay? I didn't show you this yesterday. I apologize. All right. Normally, our graph goes between 0 and 2 pi. Agree? Mm-hmm. So I'm going to put an equal here. I'm going to put an equal here. Is that okay so far? So that's normally what our period will go between 0 and 2 pi. Okay? What did I have in parentheses up here? What do I have in parentheses? X minus pi over 4. Okay? So, I'm going to add pi over 4 over here. That's equal to x. I'm going to add pi over 4 over here. So that becomes 2 pi plus pi over 4. So that's going to be 8 pi over 4 plus pi over 4, which is 9 pi over 4. That changes my period right there. And that'll work every time for you. And that's how I want to start focusing on that. I'm sorry I didn't show you originally. My error. What other questions might you come across? 12?
I did 12.
Oh, okay. So 12 does not change its height at all. Like the amplitude is just 1. And the center line does not change at all. Do you agree? So the only thing that changes on this is it's going to shift left pi halves. Okay. Cool? Cool so far? Cool. All right. So let's just graph sine x. Goes here, 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 here. And if it shifts left pi halves, what should I do with my x-axis?
Move it.
Yeah. So what is this going to become? Negative pi halves. Okay. So this is no longer the y-axis, right?
Oh, yeah.
I'm just changing.
Yeah.
I'm going to subtract pi halves from this. So what is this right here? 0. Is that okay? So now that's where my y-axis actually is now. Okay, but I'm just changing the labels of it. Subtract pi halves from that. So pi minus pi halves, that's 2 pi over 2 minus pi halves. So that's going to give me just pi halves here. Change that one. So I'm going to go 3 pi over 2 minus pi halves is
1.
Well,
It was Clay.
so funny. Oh my god. That sucks.
Was that really clear?
I don't know.
We're just gonna keep doing this.
Yeah, let's continue. Let's continue.
Citizens arrest.
2 pi minus pi is what?
Pi. It's 1.
The kid probably just like
One
pulls
time.
it.
Okay, so that's pi.
No, there's someone much bigger in the school.
And then I have 2 pi minus pi halves.
They were running. They were hightailing down the hallway.
Tell you what, I'm going to bust someone's jaw.
They're gone.
No, we don't need to go out and take a look every time the alarm goes off.
Does it turn
Because I will tell you this. That's a 3-day suspension and possible ticket from the police.
Really?
Opening
Yeah.
a door?
It's now designated as a fire exit.
That kid's gonna get suspended.
I'm just telling you, that's what it's going to come down to. It's a 3-day suspension plus possible charges filed for opening a fire exit.
Yeah, why did
That's why it says emergency exit now.
It does? Yeah. Oh.
Big, it's this big on each door.
Is it just that door?
If some kid says, well, I don't know how to read, They shouldn't be here.
This is true. Yeah, there's really no getting around this.
Come on, man. What the hell?
Is that you, man?
Yes, it was. Hush.
Try to make a run for it, man.
Jeez. All right. Subtract. So I get 4 pi over 2 minus pi over 2, which is now 3 pi over 2.
That's what I did. I ran out.
Wait.
Citizens arrest.
Done.
Citizens arrest.
Done.
So all you do is just put that like extra and switch like the sign. Okay.
So this, all this means is subtract pi halves from all x values that were on the original. And I will always label the x values as 0, pi halves.
Wow. So then, why is the y-axis different?
The y-axis is between 1 and -1. The y-axis is fine. I did not add or subtract anything out here to change my center line. My center line still stays there.
Okay.
Okay? So, center line is just y equals 0, or midline, excuse me. And then what else did we say? Amplitude is still 1. I can't spell. And if I wanted to find my new period, my new period is still going between this and this. Equal. What do I have in parentheses up there? X plus pi over 2. How do I get x by itself here? Yep, so I'm going to subtract pi over 2 equals x, and then 2 pi minus pi over 2. So I get negative pi over 2 equals x, so that's 4 over 2. That's equal to 3 pi over 2.
And that's the period, that's what, and the x is.
That's my period.
So then amplitude's just like.
Whatever is out in front of sine. So right now there's a 1. We don't put it. Cool.
Okay.
What else?
Can you do like 11?
All 11 does is goes twice as high. All right. Names on those. Fold over the corner. You don't have to worry about stapling them. Names on those. If you're handing anything else in.
But I'm happy with that.
That's so embarrassing. Tough life to do.
What? Suri didn't get expelled. I think he got suspended. No, I think he got suspended last year. He got another charge. Because I know that he had.
Thanks. All right.
Right, last Senate elections last year.
Everybody have notes? Did I pass enough? Lead? Good? Extra?
No, they also, and then he hacked his.
Mila, did you get cosine notes?
But I don't know if I got expelled.
Who didn't pass back? Who's not passing those back?
I got expelled like from people who are well, that was for hacking his teachers. Yeah.
You're not paying attention this morning.
Last year. Yeah, they hacked them. Registered. Yeah, no, that's why he couldn't represent it.
All right. All right. We get them. So go back. So cosine is going to be done very similar to sine. Okay. So on our unit circle, as we go around on this would have been the point 1, 0. This would have been the point 0, 1. This is the point -1, 0. This is the point 0, -1. Okay, so all right, so this is happening at 0, pi halves, pi, 3 pi over 2. Oops. And 2 pi. Okay, that's still the same, right? Oh, I'm sorry. So I'm labeling it 0. Pi over 2, pi. 3 pi over 2. 2 pi, right? Okay, cosine's what value of one as a point? It's my x value. Okay? So as I go around, that starts at 1, goes to 0, goes to -1, goes to 0, goes to 1. And here we go. So it's going to go up to 1, down to -1. So notice, cosine starts at a maximum. Sine started at a 0. Right? At pi over 2, it's at 0. At pi, it's at -1. 3 pi over 2, it's a 0. And at 2 pi, it's a 1 again. So that's the cosine graph. If I drew the sine graph is doing this. So this is the sine graph. Do they look similar?
Yes.
Yeah. They are just a 90-degree phase shift. Why is it a 90-degree phase shift? Well, think about it. What is that? From there to there.
90 degrees.
That's why it's a 90-degree phase shift. Ta-da! Only took me 7 years in college to figure that out. And then my 8th year, I finally graduated my freshman year. All right. So some terms you need to know. We have cycle, horizontal, and phase shift, or phase shift. Okay. Why do we need to know these terms? I don't know. I guess we'll come to them. Oh, great. Is this one that I have to remove?
No.
Nothing there. Okay. All right. 4 definitions are helpful. A function. I don't know. That's not really helpful for me. All right. So this is a cosine graph. Now, do you think on a test, if I said, hey, graph this, and you gave me as a sine function, if you had the right shift in place, do you think you're wrong?
No.
You're not, because they look the same. But let's go ahead and do this as cosine. What does my midline appear to be?
2.
What is my amplitude? So I'm going above and below. Is my 1? Okay. For the period, we could just do this. Hey, I realize on my period, it sounded really bad. This right now is going between 0 and 2 pi. So x, I'm not even going to worry about that, because if you look at it right now and just say, hey, from there to there, it did 2 pi. Cool. All right, so what is my equation? Y equals 1 cosine. Did it shift right or left? Now. So x. Did it move up or down?
Yeah.
2 plus 2. So let's clean it up. Y equals cosine x plus 2. That's my equation.
Cosine x.
It can be cosine theta if you'd like. Because this is your variable. This is what's happening on the x-axis. Sometimes they might call it theta. That's a fancy way of just saying the Greeks said, hey, we're doing this.
So even though cosine is like x on the unit circle, it's like not x here.
Oh, I see what you're saying. Yeah, no. If we take what the unit circle offers, the cosine is the x value. You're absolutely right. If you wanted to make this fancier, you could say that's theta. But you're transferring what off this graph to this graph. That's all you're doing.
Oh, okay.
So what's going on in the x direction? If you look back at this, what was going on in the x direction? This was going on in the x direction.
Okay.
Good question, though. I see eye to that. Okay, midline. What do you think?
-1.
-1? Okay. So how much taller or how much lower is it? Huh?
2.
Yay. All right. So Let's go from peak to peak.
2 pi.
It looks like 2 pi. Yay! So my equation is going to be, it's cosine, so we're starting at a max. 2 cosine x minus 1. Done. That's it.
So you don't need like a point, like in parentheses for the period?
Not right yet. Not yet. And really, actually, let's hold off on that. I don't know if we're gonna hit that or not, but I don't know if I have to teach you that complex of a thing.
Okay.
From looking at a graph going to it. Cool. All right. Midline. 2. Amplitude. 1. It's going all the way out to 4 pi before it starts repeating. So this is doing a horizontal stretch. This is something, a new term. We had been doing vertical stretches before. That changes when you multiply outside the x. That's a vertical stretch. It's a vertical compression if it's a fraction between 0 and 1. This got stretched out this way. Okay, got stretched out right and left. So it's happening more often. Now this is kind of like a backward thinking type of thing. So what should I plug in as the period? Well, right now, I think I can do this like this. Let's see if this is going to work for us. What is it normally? X plus 2 pi, usually? No, I thought I was going to do that way. I'm not going to do it. Okay, so you just got to trust me. So the period here is 4 pi, because that's where it takes place. My equation now, I agree with this so far. I'm going to reserve this for something, and I'm going to change that to plus 2. Okay. So let's think of this as a particle going along that red sine curve. Okay? That particle wants to go from 0 to 2 pi. So I went from 0 to 2 pi as that particle. How far along my path did I get in order to complete one iteration of the graph? Half.
So it's a stretch by half.
Okay? So if you think about this particle traveling along this line, if it gets to 2 pi, how far did that particle travel? It traveled half of its distance because it wants to get all the way to here. So it took more, it's going to take more time to get to there. So we're going half. Half gives us that. If this had gone from 0 to pi, it would have meant, hey, it's getting there twice as fast, so then I would have done 2. So if this graph would have done this, let's go here to here. If it would have done this, that means it's going to happen twice as fast. So we'd put a 2, so I got a half there instead. Okay, midline. 2. Amplitude. Okay. They're starting at mins, that's fine. But does it still go to 2 pi or is it slower or faster? 2 pi, cool. All right, so y equals cosine of x plus 2. And there's one thing I need to change on this. And what do you think it might be? Make it a negative in front of the cosine. Remember that negative out in front flips it over the midline. So it changes the max to a min, mins to maxes, keeps zeros the same. That's where it crosses the midline.
Oh, because on the normal ones it's going down.
Mm-hmm.
Okay.
So normally it would have went from here to here. That would have been if that wasn't negative, but because it's negative, this comes down here, this comes up here. Anywhere it crosses the midline stays the same.
So is a negative cosine a positive sine?
No, because it's at a minimum. This is a minimum.
Oh, okay.
It's still phase shift.
Okay.
All right, midline. 0. Amplitude. Is it starting and stopping?
2 pi.
2 pi? Now let me ask you. I know we're in the cosine unit, but what is this graph?
Sine.
Yeah. So I would just say, dude, duh, starts here, goes here. Yay, happy. So y equals 2 sine of x. Why is it sine? Because when I got to the origin, I looked at the origin, it was a 0. Or when I got to the midline, the graph started at 0. Okay? What do they actually probably want you to do on this one? So if this was ever on a test, dude, that's 100% correct. I love you for it. This is probably what they wanted on this answer. So there. And they actually probably wanted a negative up front because they're thinking this point was right here. So the negative means it started at a minimum. This says it shifted left. So
Seems like a lot more work.
So if you're all good with this, I'm pretty happy with that. If you're like, varsity letter math student, go for that. But it's just mean and cruel. Yeah.
But doesn't that mean that we can write like any of those lines and either sine or cosine?
Beautiful. Yes. That's a great question. Can I write any cosine graph as a sine graph? Yes. Can you write any sine as a cosine? Yes, as long as you understand the shift that's taken place. The shift is in the grouping part. Okay? All right. I don't even know why I would mess with this one other than saying, dude, that's y equals sine x. Why is that? Well, it starts here, ends here. Do I need to say, hey, it keeps going either way? No, you should know that. So, midline 0, amplitude 1, period 2 pi. Yay, life is good. Okay? All right, now let's try drawing this one. What's my midline?
-3.
-3, amplitude.
1.
And my period should go to 2 pi. Yes? So, this is not going to be my x-axis any longer. What is this going to be now?
-3.
It's going to be -3. Good deal. So that means this goes to -2 because the amplitude only goes up 1 and down to -4. Yay?
Yep.
I still have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so it's cosine, so we're going here, to here, to here, to here, to here. Done. Hey, where's the x-axis on this now? Somewhere up in this second line. We're there, right? So if you understand the shifts that are taking place, change your labels of your axes. Let's not act like our axes can't be changed in label. I mean, criminy, you do it in science all the time. Okay, we're going to start with 32 degrees, and we're going to go up to 212. Should I start at 0?
No.
Yeah, Ruben, just write out all the numbers. I ran out of room. Right?
You know, Ruben?
Yeah, Ruben Garibay. I grew up with a dude. He had the coolest bike, and then it got stolen. We were up at Super X playing Donkey Kong. It was awesome.
Playing Donkey Kong, throwing barrels down at each other.
It was funny because we're all inside. We could see out the window. And like 3 guys jumped on. One guy jumped on his bike, and the others were on. Other two were on bikes, and they took off. We're like, dude! And we were running out. We couldn't catch him. But he had a sweet bike, man. I guess that's why I got swiped.
He had a swipe.
Had is the key word. Hey, midline.
0.
Amplitude?
3.
3. Thank you for recognizing it's an absolute value. And the period is 2 pi. So, I could say that. I'm going to go up to 3, down to -3. And this is 0, pi halves, pi, 3 pi over 2. These are supposed to be evenly spaced, but I'm not the brightest guy. So this starts at a minimum. Why?
Because it's negative.
Negative. And then here, as a center line, a maximum, a center line, and a minimum again. Done.
Oh, nice. That looks like a mountain.
I do. I try. Oh, I could go skiing about now. Anyone else? I got the minivan. We can get 6 in there. Strap people to the roof. You want to be like, woo, we're surfing on top. And then all of a sudden someone shoves somebody else and they get run over. And everyone points and laughs. All right. Hey, midline. 0, amplitude. 1. What is this 3 doing? I don't know. Let's figure it out. 0 equals 3 theta. Sam, you're using theta rather than x.
Nice.
Thought you'd appreciate that. So what is my, how did I get theta by itself? Divide by 3?
So 0 equals 2 pi.
Woo, okay, here we go. 0, pi halves. These are all going to change. What do these change by? We divide by 3. That becomes a 6. That becomes pi over 3. That becomes a 6, which is 1/2. I don't know how I can make this neat. I'm sorry. And then this is over 3. It goes up. Up to 1. Goes to -1. Starts high. Goes to a min. Done.
Nice.
Woo! Am I done?
No, you still have 2 more.
2 more pages or 2 more slides?
Well, 3 more slides, but.
Okay.
More.
Okay. Where's the last one? Ferris wheel. Okay. Hey, what is midline? Midline. 0. Amplitude.
1.
Period. Oh, okay. Let's figure out what the period is. Ready? Shh.
5
Theta plus pi over 2 equals 2 pi. Subtract pi halves. 3 halves pi. Thank you. You guys are getting so good at subtracting. All right. 1. -1. And then, let's see. Pi halves. Pi. 3 pi over 2. 2 pi. Am I adding or subtracting to each of these values? So 0 minus that, that's negative pi halves. This is now 0. This is now pi halves. This is now pi. Yes? And this is negative, or 2 pi over 3. Cosine starts at max, hits the midline, goes to a min, goes to the midline up here. Worksheet is F, A, B, C, D, E, F, H, Trig, H.
Mister, you write it on the board for a reason.
Do I have it over there? Oh, you're the best. Thanks for reminding me.
Check it. You
That's
always
like
do it every day. You like think about it. You always have it written.
so much, you know.
You know, just think about for you.
For people like you, I do better in life. Guys, girls, have a great day. Take care of one another.
$20.
Don't push that door, because I have to listen to it all day. You guys are in a different building all day.
$20, I'll do it, man.